All right. So good afternoon. We continue our discussions around the technologies developed in the DataCloud project. My name is Dmitry Roman, and I have the pleasure to have here today Nikolay Nikolov, who is the technical coordinator of the DataCloud project. Hello, Nikolay.
Hello, Dmitry. How are you?
I'm fine, thank you. I'm very glad to have you here and discuss about some of the ongoing developments in the project and specifically about work around testing, simulation of data pipelines. That would be the topic of today's discussion. However, before we start, we discuss a little bit about the overall context around data management, and in particular, the context of big data. So data management is ubiquitous in data-driven activities nowadays. Can you talk a little bit about some examples of challenges in modern data management that are appearing nowadays?
Sure. Modern data-driven activities, especially with the rise of Internet of Things, they start to involve more data at higher velocity and more variety, which means that data management of these data becomes more complicated. And on the other hand, you have, in terms of how do you manage the data, you have different types of resources available to you. So when it comes to the data storage itself, you have different types of cloud platform or software as a service solutions. You have different storage solutions like hard drives, solid state drives, which are appropriate in different situations. For example, when you want to archive data, you might want to be using hard drives rather than solid state drives. If you want reliable, redundant data storage, you might go for a software as a service solution, etc. In terms of compute, so when it comes to data management compute tasks, especially in Internet of Things based systems, you have different cloud, fog, and edge resources that need to be involved in the data management activities, and potentially other resources. And it does matter how the compute and data are deployed, and that goes in both performance and cost. And in this setting where you have different types of offerings, it's kind of also difficult to set this distributed deployments up.
So is the problem of the heterogeneity of the resources? How about the heterogeneity or the multitude of technologies that are being developed? So do you think that this is a challenge that new storage solutions appear, new databases if we talk about data storage? So how do you see this variety of solutions for storage in this particular context?
Yeah, it's a problem in terms of both interoperability and in terms of, well, just pure know-how, because typically a company that wants to, or even a person who wants to do data management in this setting, they would need to be, or they would have a setup with a specific software stack, and they would understand that software stack. And when it comes to integrating more and more data from different sources, which are deployed and managed on different software stacks, one needs to, in a lot of the time, understand multiple software stacks. In terms of the database technologies themselves and data storage technologies on both the software and hardware side, one has to, the data, this heterogeneity is also problematic because of the fact that, well, things don't interoperate out of the box.
Good. So DataCloud project is centered around the concept of data pipelines. Can you say a few words what these data pipelines are, and how do you see this notion of data pipelines as part of the more general data management landscape?
Sure. So data pipelines are they're composite pipelines which are meant for processing data. And in DataCloud, we specifically look at these big data pipelines. And the idea is that you want to be processing data with these non-trivial properties or characteristics. They're known as the V's of big data. Basically, everyone knows about them as volume, velocity, variety, veracity, value, and many others, actually. And so big data pipelines in this context are used to manage large amounts of data, which includes both heterogeneous data with the variety V, but also like large volume data or high velocity data that is produced by the sensors all the time, and set this up in a way that is so in DataCloud we try to develop a solution which allows, let's say, a broader set of stakeholders to participate in the process of developing the pipeline together with the separation of concerns, and then make it possible that you can develop a big data pipeline regardless of what type of software stack you're using internally, let's say in a company, by the use of different enabling technologies.
So you mentioned the stakeholders. Can you say what kind of stakeholders you have in mind when you talk about data pipelines? Who should be involved in the process? Who should care?
Sure. Yeah. So on the one side, you have, well, let's say in the data exchange scenarios, you would have the data owners or data providers and data consumers. That's the most basic thing. So those could be the same entity, but it could be also, different companies. And when it comes to the data pipelines themselves, in terms of implementing one, there are two main groups of stakeholders. So one would be the business domain expert, who would possess, let's say, detailed knowledge of the problem domain or the business domain where it's operating, a good understanding of the value within the data and the potential way to extract the value out of the data. So let's say they would know kind of the business goals of the company and how the data could be used in terms of that. And so the business domain expert would have a good idea about what type of tasks, like high level tasks, need to be done to the data so that the value can be extracted. Then you have the stakeholder group that is involved in the implementation of the actual data processing in terms of the piece of software that does the actual data processing, and that would be, let's say, a data scientist or engineer that would have the technical know-how to write the program that actually does the processing. And then finally, and definitely not least, we have infrastructure maintainers or DevOps, or nowadays you have different ways of referring to people who are involved in infrastructure maintenance. That's both physical infrastructure on-premise, cloud, or public cloud offering managers. And so they would be in charge of managing the infrastructure for actually executing the pipeline. So these are more or less the main stakeholders. And in this picture, you could also have, so in DataCloud, we have the notion of a external, let's say, resource provider, which may, through the technologies that we're developing in DataCloud, may be able to provide what we refer to as untrusted resources that can be used in a trustworthy way using DataCloud technologies in order to provide resources for pipeline execution. So they would, let's say, add their resources to the pool of resources that is available for executing a pipeline.
Good. Another question related to this context. Does it make sense to talk about the life cycle of a data pipeline? Or is this, how do these pipelines come into being? What happens to them when they disappear?
Yes, definitely. So when it comes to development of the data pipeline, again, it's not just, you know, you sit down and you define the pipeline, you implement it, and it's done. It's a more complex process which involves different stakeholders at different stages. And so I would say, very high level, speaking on a very high level, the first thing you need to do is kind of understand the process of data production in case there's a data pipeline kind of underlying, let's say, an industrial process, and let's say discover part of the pipeline. So the first life cycle stage, I would say, in many cases, is the discovery of the existing data processing procedures, and this typically would happen based on what we call dark data, which would be a set of data that is stored but not used for necessarily processing. This is like event logs, logs of programs that companies typically store, but they don't really use for extracting value. Those are stored usually for compliance requirements. And those contain the information of what's actually going on with the data processing. So once you have this kind of idea about what's the underlying data process, if any, the next stage would be to kind of define it in terms of both what's going to be the structure of the actual data management solution or the data pipeline itself. So defining what the pipeline is in implementing the solution, and during this process or after, you know, developing, you would want to also define or to not define, test the pipeline. So test and simulate perhaps the pipeline before you deploy on the distributed infrastructure. Obviously, you don't want to do that until you're pretty sure that the pipeline works. And after this testing is done, the next thing you need to do is to schedule and provision a set of resources. And that would be choosing the right resources from the continuum of resources, or what we refer to as computing continuum, which is a way to look at, let's say, the available hardware resources, which could be cloud, fog, edge, on-premise, out-premise, and untrusted resources. So if you look at this as a pool, so choosing the right set of resources to deploy the pipeline based on, let's say, requirements of the pipeline that are identified during the simulation process, simulation and testing, and of course the constraints that the code has. And then the next step is obviously to deploy the pipeline on this infrastructure. And during its runtime, many different things could happen. So you could have, let's say, less data starting to come in or more data starting to come in, let's say, including new users to your offering that would produce more data. And that involves adaptation at runtime. So that requires adaptation at runtime of the pipeline because the data fluctuates. So these I would say are the main parts of the life cycle. And then it's a cycle because pipeline development could be continuous and adaptive regarding with respect to the conditions.
So if somebody wants to set up such pipelines and manage this whole life cycle, what kind of technologies are available to do that nowadays? And maybe if you can comment a little bit on limitations of such technologies or opportunities for the future.
Yes, so nowadays there are many different technologies that are available to do that. And that's both a pro and a con, I'd say, because you have many ways to perform this data pipeline task. But on the other hand, it's difficult to choose one way. And I would say what's kind of specific to this situation is that most of these approaches for developing big data pipelines, they use ad hoc processing models. And those are focused on optimal execution of the pipeline, so the optimal usage of resources rather than avoiding, let's call it, vendor lock-in. And then in order for you to make use of such technologies, you would need experts with specific know-how in the organization, which is not typically the case. So you would, as I said, normally companies are used to a certain processing stack and they try to keep that consistent. And then in this type of landscape, one needs to kind of come up with a way to deal with this requirement, and it's difficult to find such experts on the market. So one opportunity in this landscape is to come up with a way that you're able to define these big data pipelines in a manner that allows for more people to make use of this data management technique, big data pipelines. So I'd say that's one of the main challenges here.
So software containers are more and more popular nowadays. How do you see use of software containers for data pipelines? Are they a relevant technology that can help set up and operate these data pipelines, or you think it's a very cumbersome technology, these software containers?
I definitely think that the software containers are relevant and very much related to data pipelines. So software containers enable you to encapsulate a piece of code and deploy it on basically any infrastructure with very little limitation on the type of infrastructure. And what they do really well, and that what they were initially intended for, is distributed applications. So that's the kind of drawback. Container technology hasn't been catered to setting up a data pipeline. So containers are set up in a way that allow for a distributed deployment to connect multiple services together into a distributed application, which is scalable at runtime. And so in the context of data pipelines, one could use that, let's say, property of software containers in order to set up an approach for designing and deploying big data pipelines using containers. And in the container world, there's this container orchestration technologies, which allow you to set up a pool of resources that are managed by this container orchestrator. And the container orchestrator's role is to make sure that you have some kind of evenly distributed deployment of whatever type of software you're developing, in this case, data pipelines, that the requirements of the data pipelines are fulfilled with respect to the requirements of a pipeline step, let's say how much resources it needs and where it needs to be deployed on a cloud folding edge. And so container orchestration technology can be used once you have a pipeline which is encapsulated in containers that are associated together to deploy this pipeline in a distributed infrastructure with very little to no limitation on what type of infrastructure that could that is in the background.
So your approach in DataCloud is very much centered around the use of software containers.
Yes, that's the case. Yes. So we have based our data pipeline framework. So in the basis of it, it's containers, and we are developing the parts which are missing from the distributed application world, which is management of inputs and output data. How do you encapsulate the specific programming logic that you need for a step to execute a data transformation as part of a big data pipeline? And how do you do that in a scalable way so that you can perform this scaling on a step level on demand without disrupting the operation of the pipeline? So that involves synchronization and management of information across data communication between steps and data transmission. And you need to do that in a scalable, that is loosely coupled way. And so the framework is centered around container encapsulation, and that means also that it does not matter what type of technology you use for implementing a step, because a step is in the DataCloud view, it's a piece of code that takes data in and provides data out, and then the rest is managed by our framework. So then you could use Python, Java, or whatever you want as a step implementation, injected into a container that we provide templates for containers, and then put it as part of a big data pipeline and execute it in a distributed way on a continuum of resources.
So this brings me to my next question on how do you ensure quality of these pipelines and their steps, and how do you test this whole deployment of data pipelines? So can you comment a bit on aspects related to testing and maybe proper deployment when it comes to before actually deploying pipelines, how you would find the best setup for the resources, something that goes in the direction of simulating the pipelines. So maybe if you can say a few words about what does testing of data pipelines actually mean, what does simulation mean, and what you think are the biggest challenges in testing and simulation of data pipelines in general.
Yeah, I'd say big data pipeline development, as in software engineering, it's kind of any type of development, you would have mistakes in a way. Mistakes will happen, and you want to have the ability to identify them, and especially if you're deploying something which is highly distributed and it needs to process a lot of data, you want to be able to understand if your code or pipeline works before you deploy it. And then this type of testing simulation, that would give you the ability to understand the requirements in terms of the underlying infrastructure that you deploy the pipeline in, where you need to take care of scalability, and what kind of scalability requirements you have for the different parts of the pipeline. And yeah, especially with big data, you don't want to have to deploy a pipeline in order to make sure that it would work. That could be both costly and time consuming in case there are any types of errors. So you want to avoid any distributed deployment if possible, before you're sure that the pipeline works. So simulation, testing, these are approaches that help by providing alternative way to make sure that the pipeline works as intended.
And why is this a difficult task?
So it's a difficult task because, well, normally you don't really have the information that you need to perform a simulation, right? And the typical approaches for simulation, they would rely on data that comes from previous runs of the pipeline. And in big data terms, you don't want to run the pipeline really for testing it. So you don't test in production. Or some approaches rely on kind of expert opinion or experts saying that, okay, I expect this step of the pipeline to perform this way and to require this amount of software. And that's really kind of inaccurate, and it leaves a lot of room for providing the wrong input to a simulation, which would result in bigger error for the big data pipeline simulation. So the main challenge here is, how do you get the input to a simulator that can provide you with a simulation of what will happen during deployment without actually doing the deployment?
So in DataCloud, you are developing the SINTEF approach and tool for testing and simulation. Can you say a few words about the main concepts behind this approach and how they are implemented, how this simulator or tester and simulator is meant to be used, and whom, and something on current developments, what's happening, and when the tool will be available for use?
Sure. Yeah, indeed. So in DataCloud, we're developing an approach or framework for simulating big data pipeline, and we very much take advantage of this container-based approach for big data pipeline steps. And we do that in order to enable the testing without deployment. So as I said, you want to be doing that without having the infrastructure or having to deploy on the underlying infrastructure. And we use what we call dry runs to gather data about performance and resource usage of individual steps. And then based on that information, we extrapolate. So we would make several dry runs with different configurations and try to extrapolate what would happen in a distributed deployment. And that's kind of our experience is that it's much more accurate than trying to predict on your own, or well, it's not going to be more accurate than deploying in production, but that's really not possible in many cases. So, but it is much more accurate in our experience to actually use the dry run information rather than try to guess. And so yeah, during the dry runs, we record all kinds of properties of the pipeline, so the resource usage on the one hand, on the other hand, the time of execution, which helps us understand a bit about the scalability of the pipeline. So yeah, the idea is that if you have a pipeline, you put it in our simulator, and then you're able to test or dry run it by providing some kind of sample data, which could be, it could vary the input data volume, and see what happens. Record the performance and the timing of the pipeline, and then so currently we have the first let's call it prototype of the SINTEF dry runner, which is going to be part of the framework. That's published on our GitHub page of the DataCloud organization in GitHub, and in the future we're planning to further develop this dry run approach. We have started to work on analytics approaches related to these data that we gather. And in the future also include a simulator where this dry run data is actually inputted and can give further understanding about what would happen in production settings once the big data pipeline is deployed on the resources. Another of the so our approach relies on what we call a sandbox, which is a node that a dedicated host where we deploy each step individually and feed it data and see what happens. And we use container engine to record information about how this works. So another thing that we're working on now is to have an approach where we enable the deployment of the simulated pipeline in the actual production hardware, not at scale, but at least it's let's say you have an IoT edge device where you need to deploy an aggregator service, that you want to be able to test the aggregator service on the actual IoT device, which might have more constrained hardware availability. So yeah, many exciting things to come from the SimPipe tool, and we're very much looking forward to continuing the development.
Can you comment a bit on type of use cases where this will be applied, both in the context of the project, but also in the broader context?
Yeah, so in the project, I would probably give the example of this IoT system in digital healthcare. So we have a remote system, a patient monitoring system, where you deploy a set of sensors at the patient's home in order to monitor their condition. And throughout this monitoring, you gather the data from the different sensors, and that could be, it's a heart rate sensor, or it could be a digital scale, or any other things, including there's also video sensors in DataCloud, and that's one of our partners called Telio that they're developing this digital healthcare use case. So in their case, it's not really acceptable to push an update, let's say, to even an existing pipeline before making sure that the deployment would work. In their case, it's also, the setup is that you have the sensors, and then you have an edge device which gathers the data from the sensors directly, aggregates it, and sends it to a cloud system where it is further processed, and then different types of information are requested or pushed to the clinical staff, so the doctors and nurses that are taking care of the patients. And yeah, another thing which is characteristic of that use case is that you don't want to be able to deploy at the patient home before you're sure that it works correctly. You want to test that this type of workload would work on the limited resources. So the edge devices there are based on Raspberry Pi. And then the scale comes from the large amounts of patient data that is continuously being gathered from multiple sources, where you need to deploy a pipeline in a highly distributed way. So in their case, it's very useful. Big data are very much involved in basically any smart city or industry 4.0 development, where you have these large amounts of sensors producing data all the time, and then you need to aggregate and store the data. And once new sensors become available, you want to be able to dynamically deploy or dynamically scale the pipeline. Yeah, so the simulation information, which would give you the understanding of what type of resources you need to provision for deploying new instances of the pipeline, that's critical in that type of use case, because you can't just you can't have a good understanding of what type of resources you need to scale up the pipelines unless you have this type of simulation information and knowledge about how it works.
Okay, maybe a last question. How would you quantify the benefits of a tool like SimPipe? Is it going to be in like both quantitative, qualitative measures? Do you have something in mind when could you say, for example, that you managed to save X amount of costs for running data pipelines on the cloud, or what kind of bugs, for example, would you be able to find out? Is it going to be more like very crucial, essential, or is going to be more like flow, enabling better flow between steps in components? Can you finally comment a little bit on quantifying the benefits of a tool like SINTEF?
Indeed, yeah. So different ways to think about this. So as you said, one critical thing, especially with big data, that's cost. So once you move into the big data realm, a big data pipeline that is really processing highly distributed things, it's going to be costly to deploy this. So if you want to talk about traditional approaches versus this container-based SINTEF approach, where you use the sandbox to analyze the steps and use the information for simulating, versus traditional approach of just deploying the pipeline, seeing what happens, and then undeploying it. That would save certainly a lot of cost. So that's one way to calculate the difference. Of course, number of bugs found before deployment. So one could look at, for example, once a pipeline has been developed by someone, any bug that has been found through the testing of the pipeline, that's something that is a gain for the company, because otherwise they would have to deploy it, see that something is not quite right, investigate, and then figure out. And then it's still like bugs are costly in big data realms. I'd say the benefit in terms of accuracy of simulation is also quantifiable. So when it comes to simulators, there are plenty of approaches out there for performing simulation based on what I said before, expert opinion or previous ones. So another way to quantify the benefit of using our approach in SINTEF with the dry runs and the recording of data is how much better is the simulation result based on these data, as opposed to, let's say, guesstimates of how well the pipeline performs in production. These are several ways. Of course, there may be others, but yeah.
That's great, Nikolay. Well, we look forward to see the release of new versions of this tool, to see its capabilities to improve management of data pipelines. So thanks a lot for your time today and interesting discussion. And again, we look forward to the next steps in the development of this tool in the project. Thank you very much.